I'm Shankar Chebrolu and I work for Cisco Systems. I'm here today to share the work we have done in the OWASP Top 10 Cloud Security Project. It's a collaborative effort primarily among three of us. All of us work for Cisco. All our IT architects working in different departments within Cisco, supporting different functional group. Vinay Bansal is full-time security architect, and myself and Pankaj are IT architects supporting different functional groups. But security is not our primary responsibilities, at least not in the last few years. But we used to be primary on security before. With that, so today's agenda is I'll spend a little bit of time on about the project, to how it started and what is the motivation and the approach we took to come up with a list of top 10 security risks, which is on the similar lines of top 10 vulnerabilities of web application, which is probably the one of the popular OWASP projects. And why is that important for us? What makes us to think about cloud computing as important to spend time to analyze the risks and probably risk mitigations therein. And so the core of the presentation is around the fourth and fifth bullets, but I'm not going to go through all the risks and then risk mitigation. So I'm going to go the risk and mitigation kind of a thing. And I'm pretty sure I'll have some time towards the end, maybe 5-10 minutes for Q&A. With that, so as I said, we started as a special interest group on the cloud computing, and we worked in our previous jobs to review the security of application service providers. Now you could call them as cloud providers, depending on whether it's a software service providers or platform as a service. Based on that experience and based on the interest that we want to understand what are the new risks that the cloud providers come in with the cloud technologies and with the adoption. We want to develop and maintain the top 10 initially within Cisco, and then we thought that okay, we could use this as reusable document in the industry, and then we approached OWASP, who readily gave us the access to create a project and work on that. And not only just to come up with a list of risks that we think there are, but also provide guidelines for potential mitigations for those risks. Yeah, so the approach we took is we read a lot of research articles on cloud security and market research and academic research. We referred on IISc Square articles, NIST, Cloud Security Alliance guidelines, and all the relevant information that we could think of, and we applied our own industry knowledge around reviewing application service providers to come up with this list. And also to prioritize and order the risks R1 to R10, we used some of the elements like what is the most damaging thing that could happen, or what is the most frequent incidents that we heard in the industry. I'm not going to go through the incidences of the cloud providers in this session, even though most of them are public information. Probably there's only one slide which refers to some incidences. So why is it important? According to Gartner, cloud computing is the top strategic technology in 2010. I think it's still in 2011 and beyond. As per their projections last year, they said that global expenditure on adoption of cloud-based solutions and services may top $150 billion. Actually, last month I was reading the report from CIO on CIO.gov, which is public record or report. They're projecting in the next few years, I think in the next 4 years, they're going to spend $20 billion out of $80 billion federal IT government budget on the adoption of cloud computing services and solutions. That's about 25% of their total budget. And they gave throw a number like they're planning to close 800 federal government-owned data centers by migrating their applications and platforms or infrastructure, whatever it is, towards the cloud providers by 2015. It's just published in July 2011. So according to IDC, which is a market research firm, they did some survey, and they usually do such surveys every quarter, depending on what is the hottest topic at that time. And they came up with a list of why people are running towards adoption of cloud computing. Number one is cost, and also pay-as-you-go model. You could argue that over a very long time, pay-as-you-go on a monthly or quarterly basis may be more expensive than investing in a traditional data center. But because of the current situation where there's a lot of macroeconomic conditions and a lot of uncertainty in the market, the IT enterprises, large, small, medium companies are focusing on pay-as-you-go model to begin with, and the promises of the cloud providers like faster provisioning and time to capabilities being very low. That's according to this market research, and there are many other research reports that they show that there are many benefits, and these probably are one of them. It is a slide which I am using from my own PhD dissertation, which I did last year, which is very simplified than what it used to look like. I wanted to find the correlation among the cloud adoption, strategic alignment, and IT effectiveness. So not to discuss about strategic alignment in this session, for our agenda here, I collected data from the CIOs in the United States, which belong to different IT organizations of different type, size, for-profit, non-profit, government organizations, so on and so forth. And the data shows that, yes, the adoption of the cloud computing products, services, solutions in their respective IT organizations positively correlated and positively impacted their IT effectiveness. There are so many elements within what it means by cloud adoption, but it's for simplicity reasons I simplified. So this is another slide from the results from IDC again. Well, there are so many benefits. So why are we talking about cloud risks here? So the number one reason why the number one challenge or reason why people are not even considering for some organizations is the security, and the next one is availability. Anybody else, CIA are the three pillars of confidentiality, integrity, and availability are the three pillars of security. So the top two reasons in this picture and for our practical purpose is number one, security. So that's the core. That's a good segue to get into why we are trying to understand what are the cloud risks and how we can possibly mitigate it. The idea is not to discourage, right? I don't think anybody will listen to even if you discourage, but because the promises of the low cost and faster time to capability, faster provisioning is definitely driving enterprises, small, medium, large companies to adopt cloud technologies. But the idea here is, okay, you can adopt, but make sure that you think about your security from these lens. Not all the risks apply to all the enterprises. Not all the risks apply to all the applications. It depends on the data sensitivity and various other attributes of the cloud. So before I start R1 to R10, so I just want to refer to the cloud main actors diagram that is published by NIST. Cloud provider and cloud consumer are by the terms are self-explanatory. A provider is someone who provides the services and sells them, like WebEx, which is software service provider, Google, both SaaS and PaaS, Amazon, probably infrastructure service provider, Service, Terramark, same, Salesforce.com is SaaS provider. And consumer is one who, it could be an end user or it could be a very large organization. For example, Cisco, we use 200 application service providers, probably 5 or 6 infrastructure as service providers. As far as I know, none platform as a service provider. So it depends on the end company to company, and it could be an end user too, who could be using just the Gmail service, which is email on the cloud. The cloud broker and cloud auditor probably are relatively new terms. Cloud broker is an entity which manages the relationship between the consumer and the provider, and also it adds its own features like manage the use, delivery, and performance, and even the security. They promise enhance the security of the cloud services by, for example, use IPsec connections between the provider and the consumer. Even the provider doesn't provide that right off the bat. But Amazon, for example, they are providers and also provide a cloud broker to deploy in your data center to open a VPN tunnel between your the consumer and the provider. But you could use those cloud broker. There are like independent cloud broker companies, just like 10 years back there used to be ORBs, object request brokers, whose purpose is to broker object server and object client. So cloud broker there are many companies who are working on that. The cloud auditor is an independent organization who probably does, mostly it's relevant to the independent security assessments of the providers, but they need to collect information from cloud consumers, cloud brokers, not just security, right? They may be assessing the performance of the cloud services and so on and so forth. So just for the completeness of the presentation, right? So I just want to touch upon some of the service models and deployment models that NIST recognizes. You probably might have heard about a fourth service model, which is data center as a service, which is basically dividing that infrastructure as a service model into two different models where different players can operate as some data center service, but that's still not recognized in the industry. So we'll just focus on what is already published by NIST. So again, I think I gave examples of SaaS. Salesforce.com probably is one of the famous SaaS providers for enterprises, Gmail and so on and so forth. Platform as service, according to me, is the least mature model of these three. SaaS probably the most mature model. Infrastructure service probably in the middle. There are not many players in infrastructure service. As far as I know, Terremark, Savis, Amazon, GoGrid, and few others. SaaS, the reason why there are so many players is when 11 years back, I used to work for a ASP, application service provider, which is expensible.com. So now it's all of a sudden it's a SaaS provider, right? So Cisco itself, I don't know whether I mentioned or not, we use 200 application service providers. Most of them are SaaS providers. So for HR, for supply chain, for finance, so on and so forth. As a platform as a service model, the main key players are Microsoft Azure platform, Google Apps. Google Docs is again SaaS, but Google Apps. Cisco has got its own couple of them, but I don't know how famous are they, like EOS Enterprise Operating System and WebEx Connect and infrastructure. We use Amazon, we use Savis, we use Terremark, so on and so forth. So public clouds, all the names that I mentioned are all public clouds, and a lot of the large enterprises, they probably are working on their own private clouds. An internal data center is not necessarily a cloud, because it needs to have these 5 essential characteristics displayed down according to NIST. Elasticity, measured service, pay as you go, that kind of characteristics, right? But for some discussions, people may use internal cloud and internal data center interchangeably. But if a host or a service cannot be provisioned, in few minutes, that is not really implementing the required cloud technologies and virtualization, so on and so forth. Most of the large organizations have their own private clouds or internal data centers, and then they probably use some of the public cloud providers. That makes it hybrid. That's a hybrid cloud model. And some large enterprises and medium enterprises, medium companies may be using a data center just accessible within themselves. That's the community cloud. So it's not really, it's on premise of one particular entity or company, but they all share, but it's still a private to only those few, and that makes it's a community cloud. They're not public clouds. So this is the list of the top 10 risks that we identified. We made sure the number is 10, because incidence analysis and forensics was identified as two different initially, and then we clubbed it because it's the same kind of issues. So our objective is to keep it consistent with the number of top 10 vulnerabilities that are, that are maintained on OWASP. So we identified that accountability and the data risk is the #1 issue for cloud. And again, it depends on the data sensitivity, but the damage, if some damage happens, and this could be the biggest issue. So who is accountable for the security of your application, your data and networks, so on and so forth? Because with the 3 service models, each of the tech stack that are shown there, application to storage, are owned and operated or controlled by different players. So in the infrastructure as service provider model, which is Amazon, EC2, Service, and so on and so forth, the cloud provider has a control and provides computing, network, and storage components in the tech stack. The cloud consumer, whether it's a small or medium or large enterprise, needs to manage their own web servers, app servers, database servers, and the application on top of it, the platform and the application on top of it. So who is So the point here is that we need to ensure that cloud provider and consumer understand the accountability to secure those levels that they provide or they operate or they control, and that is true with the other 2 levels also. In the past, whoever has control on a particular tech stack level, right, they must be made sure they are accountable, and it is written in black and blue to make sure that you can always refer back to the contract and SLAs later on if there is an issue. The complexity comes in when a SaaS provider uses a PaaS model to host their application. Just for an example, right, let's say Salesforce.com, which is a SaaS provider, uses Microsoft platform in a PaaS model and deploy their applications. But as far as I know, Salesforce.com has their own their own data centers where they host their application. They own all the whole tech stack, and they provide the application as a service. But if a SaaS provider uses PaaS provider, who then uses a different IaaS provider, now all of a sudden we have at least 4 players who in that application who needs to understand, okay, now whom controls what, who is accountable for the security of the application and the data within it. So again, it depends on how sensitive the data. If the data is all public data, so then it's not a big deal. But if the data is something related to patient records, if a medical application is hosted in the cloud, a financial application which are subject to SOX regulations, or medical records subject to HIPAA regulations, or if an application which hosts European zone citizens data, which are subject to strict privacy laws. And these cloud providers, they have global data centers all over the globe, and they're in different geographical locations, and for the performance reasons, the users are routed to the nearest data centers to meet the performance SLAs. And now all of a sudden, just think about the complexity. If you have 4 providers and data is distributed all across the globe, and the sensitivity of data is high, then we need to really think about it, whether does it even make sense to move such kind of an application and data to cloud. So again, the mitigations, as I said, is well-established RESI model. So all needs to be written down, make sure it's in the SLA's contract that who is accountable to the security of which application. But at the end of the day, it's the cloud consumer is the main is responsible for the, let's say, patient's data, right? If United Healthcare or some healthcare insurance companies host their application in the cloud, then in the complex model that I mentioned, is the ultimate responsible for the patient, but United Healthcare needs to understand who is accountable for the security and who is doing what. and especially if you have in a multi-tenant model where where the infrastructure or platform or the application hosts data belong to multiple consumers, multiple customers, so obviously it just increases the risk. The second risk is user identities, proliferation of user identities. In the previous example where I said Cisco uses 200 software service providers, and let's say a Cisco employee uses even 10 of those applications hosted at 10 different service providers. So and each vendor, whether it is a inbuilt application that you deploy in your data center or on the cloud, they will have their own authentication and authorization mechanism to make the application complete. So if each of those providers create an account or identity for each of the employees of the consumer or the users of the consumer, and store it their own user store, whether it's LDAP or database, then you basically can think of the not only the user experience of the users using these applications without having a single center, and especially when you're moving back between the applications, finance to HR and HR to some other applications, you end up not only user experience issues, but you would think what happens to the life cycle management of those user IDs. If an employee of, let's say, Cisco leaves the company and joins a competitor, right? In a traditional data center model, the employee records are terminated right away. The credentials are destroyed, assuming there's an automated HR process, especially in large companies. But because these identities are available in the cloud, so the employee who just left this company and joins the competitor company can still access those identities, if assuming there are no appropriate controls, and access, whatever depends on the data sensitivity. Again, is it the sales promotions or pricing models which they can use as the time goes. So probably most of the people are already using this. So the solution, the mitigation is to use identity federation. So I'm sure large companies are already using SAML-based federated identity federation. Ping Identity is one vendor, and there are other vendors like SiteMender and so on and so forth, Oracle, who provide identity federation in the sense that there are several ways of implementing that, but the recommended model is not to replicate the user identities across these providers. So just to keep the enterprise shown in the middle, right, in the identifier, they should have the user ID and password or credentials within their control, and all the providers needs to pass the tokens back and forth to authenticate the user. The advantage is that the moment the employee leaves, you can control at one place, and same user ID password for all the applications. And of course, with the proper implementation, the users enjoy single sign-on across all the applications. And apart from identity federation, right, so there is another called OpenAuth, which provides backend integrations. You might have seen on Google and Facebook, where you can log into one application and the other will recognize that. So there is some OAuth integrations that are already implemented across some matured cloud providers. And again, automated user lifecycle. If you cannot force the cloud providers to come to your user store for authentication, you need to at least implement a mechanism to automate the user termination or lifecycle management of the user identities in place to make sure that the user's access is terminated right away. There are some cloud providers where you cannot enforce it. For obvious, there are some technical reasons also, and the business models work that way. The third one is regulatory compliance. The point here is the complexity to demonstrate that your applications are compliant to the regulatory laws like SOX or HIPAA. When SOX first came around, I think we spent like $20 million to implement the controls across the various levels in the organization, at the business users level, IT admins level, IT developers level, there's so many, right? So now if your application that is subject to regulatory compliance with a HIPAA or SOX, you're deploying in the cloud. So how do you ensure that those same kind of controls that you implemented in your internal company or enterprise are also implemented there? So it's just the complexity in demonstrating. You need to still prove it to whoever it is who is assessing your applications and data to get your SOX certification or a HIPAA certification. And again, European Union laws are very strict on the use of privacy data, and if the use citizen data is hosted in data centers other than Europe, and they don't really understand, the data centers operated in those geographical locations are not implementing those similar kind of laws, then the complexity comes to demonstrate that. So the mitigations again is apply risk management framework case by case basis. It may or may not make sense to move a SOX or a HIPAA application into the cloud, public cloud, and come up with a predefined RACI model. Again, some of these mitigations may fix multiple risks or at least manage multiple risks. Define data protection requirements and SLAs. Let's say if there is a SOX, then you need to implement separation of duties and so on and so forth. So the fourth one is business continuity and resilience. If an application is business critical and revenue impacting, and if the cloud consumer migrates the application into the cloud, right? Then what are the implications if the data center of the cloud provider are impacted by either terrorist activity or man-made or natural disasters, right? So if the data center is on the belt line of in an earthquake-prone zone or hurricane or whatever, and if the application that you just deployed or migrated to cloud is revenue impacting or business critical, so we need to make sure that the application can be brought up either manually or automated within the SLA requirements. So and some applications, ordering systems, let's say if they are down for 1 hour, it may result in millions of dollars of loss. So who is paying for that, and who is penalized for those such kind of risks? And make sure that the data centers of the cloud providers are built as per the industry standards, and they are in active mode. If one data center is down, the other is still running, and be online immediately or automated, or at least in a manually bring online, but within that key SLA timelines. The next risk is the secondary usage of data. Okay, so you might have noticed that if you send an email on using Gmail to someone about your trip, so next time you log into Gmail, you will get all the advertisements related to that information. So someone is, obviously Gmail is data mining that information, and from their perspective, they are providing some features or trying to help their users about your trip. But is all data treated like that? Sometimes, okay, finding the restaurants or some information related to your trip or travel is good, but if it's a patient information, right? So do users like the fact that, okay, now we are getting advertisements related to your the health defects of the patient, the life insurance policies related to that information and all that. So the point here is, who is in control of your private data, the cloud consumer? Are there policies to protect the privacy of the cloud consumer? So now, are the cloud provider who have physical access to the data in their data centers, can they sell it to the third parties who could then market that information or use it for business, for their own business? But the problem is, how does it impact your privacy? And how does it impact European Union data, and if the data is across the jurisdictional borders. You cannot even do anything about it. Sometimes the data is stored somewhere else other than outside the US jurisdiction, for example. Again, the mitigations is we need, the cloud consumer needs to make sure they work with the cloud providers to come up with a policy, how the data is used, that the data should not be used in the ways that it could impact the cloud consumer. Data is encrypted, de-identification of personal information, and so on and so forth. And also, main thing is the consent, whether the user wants to opt in for those kind of data mining or secondary usage of the data, or could they opt out of those kind of secondary usage. The next one is the service and data integration. This is one of the models that we are working at Cisco, where the users, right, use cloud brokers to access multiple cloud providers, and more applications that move out of their internal cloud or internal data center to the public cloud, the more and more requirements come back from those same business units to connect back into the enterprise data stores. So you migrate the application, but you cannot really sometimes you may, in case of federal government, they are saying that they are going to close down the data centers, some of them, but in a typical organization, you probably still, in a hybrid cloud model, you still will host some of the applications in the internal cloud and some outside. So the more and more applications go out, the more and more requirements come back to integrate with your internal databases. So how that the data in transit and data in storage where it is stored at multiple integration points, how secure are they? Right? That's another risk. So make sure that data at rest is secure, data in transit is secure, whether it's two-way SSL mutually authenticated between the any two entities in the transit, and the data is all protected through some kind of secure tunnels, and different unique encryption keys are used for different customers. Let's say if Salesforce.com is hosting an application and it has like 100 customers hosting 100 applications, 100 customers' data. Are they all protected by the same key? Well, it's all encrypted, but it's the same key, or it's unique keys for per customer, and who has access to those keys needs to be made sure. The next one is multi-tenancy and physical security. So the physical centers of data centers is obviously important. So if there is a theft at a data center, right, and it has multiple customers' data is on that disk, on the host or resource, whatever it is. So it impacts multiple customers in a multi-tenant model. In a single tenant model, if some, where each got their own physical or at least logical controls around customer data, the risk is less. But in multi-tenant model, where there are web servers or web tiers are shared, app tiers are shared, database tiers are shared, and they do reach back to their respective enterprises, right? So how tight are those controls? Can one application VM or JVM can open a socket connection to another JVM because they're all running on the same physical host? What are the policies? What are the Java policies, for example? How tight those connections across these processes with running in the same VM or managed? Yeah, so the commingled tenant data and malicious or ignorant tenant or tenants are basically the risks in this model. This is just an incident. I'm not going to go deep, but about the WordPress especially, right? An uncoordinated change in a database in last year impacted hundreds of tenants, including CNN. So there was no change management in place. So they thought that it's a very simple change. They did not notify the tenant that there's a downtime or there is some change management happening. They made a change, and that impacted hundreds of people. How many times a small ACL change done by network admin impacts hundreds of applications within one data center, within one enterprise. So the point here is, if the change is related to one tenant, right, it needs to be architected in such a way that it impacts only that tenant. So make sure the security controls are architected for multi-tenancy, so that one change cannot impact the other one. Controlled and coordinated change management, letting the customers know that something is being impacted on your data center, on your VPDC, virtual private data center, and regular third-party assessments are done to make sure that the multi-tenancy is secure for you to adopt, for the cloud consumers to adopt. The same architecture diagram is basically repeated here to show the more the complex architecture it is, the more security issues that come in, right? So complexity is the enmity of security. So when the data is traversing across these multiple integration points, and if there is an incident somewhere, I don't know how many of you worked in the incident management or P1 support, which I used to work before. When there is an incident of an outage of an application, so you need people from different infrastructure teams, business or IT, to contain that incident and fix it. So now you are dealing with multiple companies. So SaaS provider using a PaaS provider, using an IaaS provider, and a cloud consumer, all on same one bridge to contain an incident and resolve an incident, where it is happening, why it's happening, and so on and so forth. And the reason why we clubbed that forensic support also within the same risk is, if there is an incident and if there is a crime related to incident and FBI needs to investigate, and they say, okay, freeze that disk. Now, freeze that disk, I need to do the analysis. Okay, now you have an incident related to one customer or one cloud consumer, but due to the multi-tenancy, you have data related to multiple cloud consumers on that. So what does that mean to the rest of the customers? If you freeze the disk, can their application run, or their data is accessible? Is it something else? So as I said, detailed forensic VM images to make sure that when such a incident happens, where it's FBI says freeze the disk, there needs to be some model for the application to continue to run. Maybe duplicate disks, or duplicate application tiers, or duplicate data centers again goes back to risk for the business continuity and resiliency. And comprehensive logging to make sure that you have enough, the cloud provider has enough data to analyze when there is an incident, but at the same time, it should not compromise performance of the application. So there needs to come up with some kind of a comparable model to balance of those two. So there's the next one is infrastructure security. The important point here is it doesn't apply just for IaaS providers. SaaS providers, PaaS providers, they all have infrastructures where their platforms or applications are running. And if there is a SaaS provider like Salesforce.com, how secure is their infrastructure? Is the network, the storage, the host, whether the ports are open, unnecessary ports are open, or is that the default configuration passwords are properly changed or managed to make sure that they don't fall prey to the malicious parties who are actively scanning the internet for such applications or services. So again, the third-party audits, again, as I said, right, some of these mitigations could resolve multiple risks or help in improving multiple risks. The third-party audits and vulnerability assessments of those providers, like let's say this infrastructure is certified by this particular cloud auditor, and make sure that those get enough information from the provider, what controls they have to harden the network, harden the infrastructure, and do they have segregation of duties. And again, this applies for the SOX compliance and other compliance. Tiered architecture with appropriate security controls in between, so that even if it's a difference in depth, even if there is a web server which is compromised, make sure that the next level, which is app server tier, is not compromised. Even if they could get to that level, make sure that your database is really secure. So the last one is risk exposure of non-production environment. So in general, the mindset is an application which is not yet ready for production may have some bugs in it. It could be application bugs, security bugs.
Now, if you're adopted a IaaS provider, infrastructure as a provider, or PaaS provider, and you're developing an application and deploying there, it's not yet ready, but it's on the public cloud. So all the bug fixes are not yet fixed or identified, even if they're security or non-security issues, but it's all on the public cloud. And when they're testing, if the data is, their testing is with the production data, so obviously that will give a lot of exposure to unnecessary exposure to your production data through your non-production environment. Again, the risk mitigations use multiple layers of authentication. We are using VPC model for non-production environments, virtual private cloud. So it's in the public cloud, but still it has the VPN gateways as a proxies for the developers need to use virtual private cloud clients or VPC client to even get to the non-production for development of their applications. And don't use cloud for highly sensitive application. That's that's the safest one if possible. And make sure that production data is masked before it is copied to the non-production database for testing. So the summary is manage your cloud risks to sleep like a baby. So that you don't keep they don't keep awake you at night. Okay, thank you.